Alright guys, this is starting out fun. Computer crashed. Luckily I was able to save most of video number 2. This is going to be a really short video. I just want to show you about G-Power and the way that works, and that's what I was actually planning to do in the previous video. So this is technically video 3, but it's probably going to be 5 or so minutes at most, unless the computer crashes again. Guys, what we know so far is the problem that I'm using as the example is we're testing the mean of 500 against a mean greater than 500, alpha level 0.05. We collected a simple random sample of 100 students, which had a mean of 536.82 and a sample standard deviation of 117.46. We carried out the test of hypothesis, the test statistic 3.13, which tells us that our sample mean was 3.13 standard errors above the claim in the null hypothesis. Our p-value was 0.0011, which tells us that there was a 0.0011 probability of attaining a sample mean as extreme as ours by chance alone. The 95% confidence interval spanned from 513.51 to 560.13, validating that it appears that the students in this school district who graduated from high school do have a mean SAT higher than 500. That we then got into calculating the effect size. The effect size was 0.31, which we would classify as probably a small, but I'm going to give a little wiggle room here and call it a small to moderate effect. Now, I asked you to download G-Power. We're going to use G-Power quite a bit in this class. So let me show you what I would do for this. First of all, we go to the test family and we conducted a t-test, and I would come down and do the difference from a constant, so we just have a one sample case, so the simplest of designs. The two things I want you to focus on here, even though there are 5 selections, is look at the prior, look at the post hoc, and then even sometimes we may get into the to a sensitivity calculation. So let's just run through that and I'll explain what these mean. Okay, a prior is going to take the number of tails. In this case, we've done 1. It's going to take the desired effect size. So let's say that someone says, yeah, I'd like to achieve at least a 0.50 effect, because that is a from Cohen's D. That's okay, guys. Too many distractions today. Okay, so 0.5 is a moderate effect. Our alpha value is 0.05, and let's say that we want to achieve a power of at least 0.80. Well, I can come down and do calculate, and wham bam, thank you ma'am, it's going to tell me that my total sample size needs to be 27 students. If I do that, I'm going to have a power of 0.81. You know, that would be something that you would run prior to conducting your analysis. It tells you the sample size that you need. Now, let's say that someone comes in and says, well, I'm not really happy with 0.5. I'd like to have a 0.8 effect size, and I'd like to have a power of 0.90. Well, as you would expect, sample size a little smaller. Sample size would just be 15. And so the effect size going to 0.80 really changes things. Now let me see something here. Yeah, effect size D. Okay, so we are using Cohen's D. Okay, now if once things are said and done, and we've actually calculated and we've already conducted the t-test, which is what we did here. We did a one-tail test. Our effect size was 0.31. Our alpha was 0.05, and we had a sample size of 100 students. Now this is going to come in and tell us our achieved power. So you can see that our achieved power was 0.92. Our critical T, that just tells you the kind of the line in the sand between reject and fail to reject, would be 1.66. The other thing I want to point out is sensitivity. And this, if we put in the number of tails, one tail, the alpha level, our desired power, and our total sample size of 100, it'll actually calculate the effect size. So our effect size will be 0.25 in this case. You know, we didn't calculate the power for our test, but let's say that we had a power of 0.90. Then you're going to see that our effect size is going to be closer to the 0.31 that we actually ended up. I think when we did the prior, I think our effect size was like 0.91. So this should probably get us close to the 0.31. So guys, that's really all I want you to know there. We're gonna, you know, the good old days of just calculating your test statistic and your p-value and making your decision and calculating your confidence interval. Those are over. We'll always investigate effect size and many times we'll conduct power analysis. So, guys, that's it. Have a good one.